Welcome to Big Data Now. Today we're going to break down an important topic: how does Databricks store data? If you've worked with data lakes, you know they can be messy. Files get duplicated, data gets corrupted, queries slow down over time, and managing schema changes is a challenge. This is where Delta tables and Databricks come in. They are built on Delta Lake, which brings structure and reliability to data lakes, making them as powerful as traditional databases, but with the flexibility of cloud storage. In this video, we'll talk about how Databricks organizes and stores data, what makes Delta tables different from regular data lakes, how Delta Lake enables reliable, high-performance data processing, best practices for storing and optimizing data in Databricks. By the end, you'll have a clear understanding of why Delta tables are the future of data storage. Let's get started. Part 1. How Databricks stores data. Databricks is a cloud-based analytics platform built on Apache Spark. It's designed for big data processing, analytics, and machine learning, but none of that works without a solid storage system. Unlike traditional databases, Databricks doesn't use its own proprietary storage. Instead, it sits on top of cloud object storage services like AWS S3 Azure Data Lake Storage, ADLS, Google Cloud Storage, GCS. This means Databricks doesn't move your data anywhere. It keeps everything stored in the cloud while providing a structured way to access, manage, and process it. To do this effectively, Databricks uses Delta Lake, an open-source storage layer that improves on the weaknesses of traditional data lakes. Part 2. What is Delta Lake? A data lake is great for storing large amounts of raw data, but it has some serious limitations. It lacks transaction support, meaning multiple users writing to the same dataset can create inconsistencies. Schema changes can break queries, and over time, performance degrades as more and more files get added. Delta Lake was designed to fix these issues. It's a structured storage format that sits on top of your existing cloud storage. Here's what makes it different. ACID transactions guarantees consistency when multiple users write to the same dataset. Schema enforcement prevents accidental changes from breaking your data model. Time travel lets you query previous versions of your data. Optimized storage uses indexing and file compaction to speed up queries. Batch and streaming support handles real-time data ingestion and historical analysis in the same system. With Delta Lake, Databricks transforms raw cloud storage into a high-performance structured data layer that can be used for everything from BI reporting to machine learning. Part 3. What is a Delta table? Now that we understand Delta Lake, let's talk about Delta tables, which are how Databricks organizes data within the system. A Delta table is just like a regular table in a database, but instead of being stored in a traditional database engine, it's stored in Delta Lake format on cloud storage. Here's how it works. When data is written to a Delta table, it's stored as Parquet files in the cloud. Every change to the data, whether an insert, update, or delete, is logged in a transaction log. Databricks uses that transaction log to maintain consistency, track changes, and optimize query performance. This is different from a standard data lake, where files are just dumped into cloud storage without structure. With Delta tables, you get version control, so you can roll back to previous states if needed, reliable updates and deletes, unlike standard data lakes where modifying existing data is difficult, faster queries since Databricks automatically optimizes how data is stored and accessed. Let's take a simple example. Imagine you're working with sales transactions. If you store them in a traditional data lake as CSV files, querying them can be slow, and if something gets updated, there's no easy way to track what changed. But with a Delta table, every transaction is logged, changes are easy to track, and queries are much faster. Now let's go deeper into some of the features that make Delta tables so powerful. 1. ACID transactions. If multiple users are writing to the same dataset, traditional data lakes can create inconsistencies. Delta tables use ACID transactions, ensuring that every change is processed in a reliable and structured way. This is especially useful in financial services, healthcare, or any industry where data accuracy is critical. 2. Schema enforcement and evolution. One of the biggest issues with traditional data lakes is schema mismatches. If someone adds a new column or changes a data type, it can break existing queries. Delta tables prevent this by enforcing schema rules, but they also allow schema evolution, meaning new fields can be added without breaking everything. 3. Time travel. Every time you modify a Delta table, Databricks keeps a record of the changes. This allows you to query past versions of the data without having to restore backups. This is extremely useful for auditing, debugging, and comparing trends over time. 4. Performance optimizations. Traditional data lakes slow down as they grow. Delta Lake solves this by compacting small files into larger ones, improving read performance, indexing data so queries are faster, caching frequently accessed data, reducing the need for repetitive reads. This makes Delta tables significantly faster than traditional data lakes, especially when working with large data sets. Part 5, Best Practices for Storing Data in Databricks, 3 to 4 minutes. If you're using Databricks and Delta tables, here are some best practices to follow. Partition your data. If you store sales data, partitioning by date will speed up queries by limiting the amount of data that needs to be scanned. Use auto-optimize. Databricks has built-in optimization features that automatically compact files and improve performance. Enable Delta caching. Caching frequently accessed data makes queries much faster. Use Delta Live tables for streaming data. If you're working with real-time data, this feature ensures that updates happen seamlessly and efficiently. Following these practices will help keep your Databricks environment running smoothly while keeping storage costs down. So, how does Databricks store data? Instead of a traditional database, it uses Delta Lake, which sits on top of Cloud Object Storage. Instead of raw files, it organizes data into Delta tables, which provide ACID transactions, schema enforcement, time travel, and performance optimizations. This combination makes Databricks one of the most scalable and reliable platforms for storing and analyzing big data. Are you using Delta tables in your projects? Let me know in the comments. And if you found this helpful, make sure to subscribe to Big Data Now for more insights on Databricks, AI, and big data best practices. Thanks for watching, and I'll see you in the next